In this video tutorial, we will solve this algebraic problem number 1 of medium difficulty level. Here we have to simplify our complicated algebraic expression. It's not algebraic expression, strictly speaking, since it has a square root, but anyway, this expression can be simplified, and let's investigate how to do it. Okay, first of all, to simplify our expression, we have to note that for this expression, for this quadratic or polynomial of power of degree 2, we have a result that if we have ax squared plus bx plus c, this can be factorized and can be written as a times x minus x1 times x minus x2, where x1 and x2 are roots of equation of quadratic equation a x squared plus bx plus c equal to 0. So if we know the roots of our quadratic equation, we can write this equality. If you watched my beginning of algebra playlist, you know Bézout theorem and the fact that if you have roots x1 and x2, and these roots are integer, these roots must divide a free member of our quadratic or polynomial of degree 2. For this polynomial of degree 2, we can write that this is equal to x plus 5, since the first root of our quadratic equation is minus 5, which divides free member minus 5, and second root is 1, so we can write it as x plus 5 times x minus 1. Along the same way, for this quadratic term, we can write that this is equal to x minus 5 times x plus 1. And all in all, our expression is equal to if we rewrite our expression, this is equal to x plus 5 times x minus 1 plus x minus 5 times square root of x squared minus 1, and divided by x minus 5 times x plus 1 plus x plus 5 times square root of x squared minus 1. And here we know that square root of x squared minus 1 can be written as square root of x minus 1 times x plus 1. And this is equal to square root of x minus 1 times square root of x plus 1. So for these two terms, we have this, and our fraction can be written as, if we take out, let's rewrite first. It will be longer, but you will understand better. I'm just rewriting it. X minus 5 times x minus 1 times x plus 1. And here it will be x minus 5 times x plus 1 plus x plus 5 times square root of x minus 1 times square root of x plus 1. And now, obviously, we can, since this term is equal to x minus 1 times x minus 1, and here we have to remember that by the condition, by initial condition, x must be bigger than 1. That's why this square root is valid. And let's take out of brackets these two terms, square root of x minus 1 and this square root of x minus 1. And here, for denominator, we have this is equal to x square root of x plus 1 times square root of x plus 1. And here we can take out of brackets square root of x plus 1 and this square root of x plus 1. And here, as I noted, these two terms. And if we rewrite, it will be, if we take out of brackets square root of x minus 1, we will have x plus 5 times square root of x minus 1 plus x minus 5 times square root of x plus 1. And in denominator we have square root of x plus 1 times the brackets x minus 5 times square root of x plus 1 plus x plus 5 times square root of x minus 1. Now we note that these two terms are in denominator and numerator are equal, and we can cancel these two terms, and the final answer for our problem will be square root of x minus 1 over square root of x plus 1, or using features of square root, this can be written as square root of x minus 1 over x plus 1. And this is the final answer. So our initial problem, this complicated expression is equivalent, after transformation, equivalent to this simple expression. Like us and subscribe, and thank you very much for your attention.